CS on Air in association with Women Tech Makers. This is number 6 in our series of informal interviews with female engineers at Google, and we're learning what motivated them to pursue a career in computing and what excites them about the field today. So today we're chatting to Emily Soldal, who is in our Stockholm office. My name is Alison and I'm in Zurich, and Lynette is with us from London. So Emily, to hand over to you, could you just start by telling us a little bit about your career and the kind of things you work on at Google?
Sure. So I started doing a bachelor's in software engineering in Manchester in about 2004. Then I did a master's in database and web-based systems. Worked at a couple of smaller companies prior to coming at Google, and was recently started Google about 6 months ago. And I work on the chat and real-time infrastructure here at Google. So that is Google Talk and Hangouts and cloud printing and a lot of interesting stuff.
Fabulous. And are there any projects that you've done that you kind of look back on especially fondly?
Outside of Google?
Yeah, can be, yeah.
Sure. So outside of Google, for my master's thesis, I did a exploratory thesis on how to do tissue selection in MRI scans. So MRI scans are a little bit difficult to interpret. Mm-hmm. Unlike X-rays and CAT scans, you can't tell the difference between where muscle starts and where tendon stops. Mm-hmm. And a couple of other smaller problems that make it very difficult to identify exactly what sort of tissue you're looking at. So
is it kind of like an image recognition sort of problem?
It's sort of like an image recognition. The idea was basically to take 2 MRI scans in short succession. Mm-hmm. So you take 2 images at the same time with slightly different settings. And then you use mathematics to identify the different difference between the two, so that you can go, this is this type and this is that type, and then you can get a much more clear picture. This used a process called tricubic interpolation to sort of identify the difference between the two.
I won't try and say that again.
It was a lot of fun. I would like to revisit it. I think that my programming skills and my understanding of the problem domain has become much better.
Yeah.
So maybe one day I'll revisit it and see if we can do something fun there.
And did it ever get kind of used in a hospital or anything?
No, it never got used. It was an exploratory thing. So we proved that essentially it was possible, but at the time it was very, very inefficient. It was very difficult to get any good results out of it. Okay. But I believe that there's still a chance there. It's still a thing you can do. But
cool.
This sort of technology is very, very common in hospitals, actually.
Mm-hmm. Cool. Thank you.
And how did you first get started in computing? What was the hook that really pulled you into it?
The hook for me was probably that when I was about 10, 11, my parents moved to a different country, and I started at an international school. So all of my friends were scattered all over. Like I could no longer really go to my best friend or whatever. So I had to basically go to the internet and find other ways of being social, because I couldn't speak the language, and it was just a little bit strange. So I started going online, talking to my friends there, using various chat clients and etc. And then I started playing around with how these chat clients actually worked and what you could do with them, and if they could be configured, or if you could actually do scripting in them to change their behavior or change their styles and settings. And then I just read the manual and got completely hooked.
Cool. Fabulous. I mean, what do you think is the most amazing thing you've seen created by computer science so far?
The most amazing thing created by computer science so far would probably be, technically, I think, or from a technical perspective, I think it would probably be something like Google Search, even though that's slightly self-promoting. But I think that the fact that you can get an answer to a question in such short time, I mean, we're talking about like pretty much the volume of human knowledge being searched and answered in relatively like milliseconds.
Yeah.
I think the power that gives us is just fantastic. Just being able to look things up and just have the answer there.
It's funny, how much we end up taking for granted, but actually you're right.
I Google everything now.
Yeah.
Like, I've become very lazy with actually like remembering things. I look it up. But when it comes to other things, I think probably Wikipedia, being the largest volume of human collected knowledge ever. I think that's a fantastic project, and I think it's I don't know. I just think it's marvelous. Like, everything is on there. You can look it up, and most of the time it's correct.
Yeah, cool. And I know it's really hard to look forward in computer science because, like, a year is a huge amount of time. But I mean, is there anything in particular that you can see that's on the horizon that you're really looking forward to?
Oh, I dabble often in thinking about the horizon.
Yeah.
I would say one of the things I'm really looking forward to is something called memristor technology.
Say that again. Yeah.
Memristor technology.
Memristor, okay.
Yeah, so a memristor is a particular type of electrical component that's very recently been discovered, but it was mathematically proven like about 100 years ago or something. It was we just couldn't figure out how to make them.
Right.
We've started making them, we're starting experimenting with them, and they have interesting properties that let us treat them both as CPU components, as in the things that do the calculations and do the processing, the thing that is the sort of the brain, but also you can treat them as memory, which means that you have this one component which is both CPU and memory.
Wow, okay.
There's an interesting
So does that mean like computers will get smaller again then because it's all in one, or?
I think eventually you will literally just be able to buy computers by weight. You just go, I want this much, and then you'll get that much, and it doesn't matter if you want to use it for memory or for CPU.
Yeah.
You just get as much as you need, and then you use it, and it'll be wonderful. And it has a lot of interesting things with like power usage and stuff. So I think you're going to get like super tiny phones that never have to be charged because you just have them out in the sunlight and then they charge themselves, and that's all you need. So.
Oh no.
Wow, I would love it if I never had to charge my phone.
Yeah, I run out of batteries so quickly these days.
Well, I'm looking forward to you solving that problem, Emily. So, what's your advice for someone at school today who's thinking about computer science? How could they tell if it's something that that suits them, that they would be good at doing?
So computer science I feel is very much about creativity. You have to be able to be a creative problem solver, and you have so many different problems. Like as I sort of dipped into here, you have an entire branch of medical computer science, which is dealing with computer science in terms of medicine and understanding all of the sort of weird things that happen there, and how you can improve on that by using clever software techniques. You also have this in pretty much every single field of human endeavors. There is always some sort of computer science approach, and it's usually a problem-solving thing. You have to be able to think a little outside of the box, maybe be able to approach the problem from a different angle. But if you enjoy solving puzzles, if you enjoy solving problems, if you enjoy finding the optimal solution for something, like if you are the person who packs your bag and you pack your bag with everything like lined out so you get absolute ultimate amount of space usage, then maybe you could be a computer programmer.
Yeah, cool. I mean, some people on the chat rooms we've been seeing have kind of been curious about what age you think might be the best to start computer science. I mean, how young were you when you got started, really?
I was 11, so I started pretty young. There isn't really any definite age, but I always think that because computer science is such a generalist field, like you need to know, well, you don't really need to know, but you benefit from knowing a lot of different things. The more you know, the better you're going to perform, or well, maybe not perform, but you're going to enjoy your work more. You can find more interesting solutions to things. And so I think that if you have an interest in starting computer science, you should just start it. like you should look around you. Do you understand, how your social networks work? Do you understand how email works? Maybe make your own webpage. Play around with technologies and figure things out. It's not so much about making the next greatest thing at the age of 13. That's not really a very good approach. But make a lot of things that don't work perfectly, and then learn from them and make better things as you go along. I mean, I remember a lot of the things that I wrote when I was 11, and they are terrible. They are really, really bad, but at least I learned something from them, and I moved forward.
Cool. Coming back to something we were talking about right at the beginning, actually, and I forgot to ask you, was you told us a little bit about what you do here, but I'm really curious about sort of what your average day is like, and sort of what it's like, the teams you work with, that kind of thing.
So my average day is I usually come into work, grab a yogurt, grab a coffee, sit down at the computer, start reading my email, making sure, I get ramped up for the day. I know that my priorities are going to be in the right area. Then I will, if I'm going to do programming that day, I will usually put on some good music.
Cool.
Put on my headphones. Music is absolutely essential for me to do programming.
Okay, so what's your current favorite programming song?
That I don't know. I'm listening sort of to a radio right now.
Okay.
But I mean, like for me, programming is very much like getting into the groove of things. I mean, I need good music. It's a lot of fun, and I just have to. I don't know. It's like I really enjoy it. And
I remember you telling me once actually before that you put on your music and you really get into the zone.
Yeah, I get into the zone, and time flies, and I'm just having so much fun, and just getting on with it. It's just solving puzzles all day, solving problems, and making things better and cleaner and prettier. And then at around 12, 1 o'clock, my coworkers come over and go, "You have to eat at some point." I'm like, "Oh yeah, I have to eat at some point." So these days I'm doing a lot of hardcore programming, which I'm really, really glad for.
So what is hardcore programming? Is that like just really dedicated programming, or?
Hardcore programming is pretty much putting on awesome music and solving problems and just having a lot of fun. I mean, it's really a lot of fun because I think this is one of the things that people don't recognize a lot with computer programming is because it's a problem-solving approach, a problem-solving task, and it's a creativity task. You have to be smart about how you solve the problem because there are a million solutions to these problems, but there are some of them that are prettier than others, and so you have to figure out these good solutions. Every time you solve something, every time you make something pretty, it's like, yes, I solved this, I made it, awesome, and now I can go on to the next thing, and you just continue on this iteration, and you just make things that are fun for people to use. I mean, you can as a user of a product, you very often realize what is a well-designed product and what is not a well-designed product by how the product actually behaves. Like if it's laggy, if it sometimes misbehaves and things don't actually act the way you're expecting it to, then it's probably a design flaw in the application itself.
Right. Interesting. Cool. Thank you.
Yeah.
Great. So thanks very much, Emily. I just have you got sort of one final piece of advice you could share if you're a child or a teenager sort of just wanting to start out today, go out today, tomorrow, to start doing something? What would you do?
Well, I would just start. I mean, that sounds maybe like a vague solution, but make a web page, get a Lego Mindstorm thing, get an Arduino, play around with it, read a little bit of the manual. I often suggest to people who want to start programming to start doing web programming. Web programming has a very quick turnaround, so you can get a sort of feel for what you're actually achieving very quickly. And I think that's important. You want to get feedback on what you're producing. No one likes sitting there and writing code and not getting something back. So you have to have a development cycle that actually helps with that. when you're a fresh developer, that is sometimes a little bit hard to establish in a new program, or sorry, a new language. So web languages are very good for that, and that they have very quick and easy sort of turnarounds. So make a web page, for example.
Perfect. Thank you very much. Well, let's hope there's a bunch of people out there who are going to go home tonight and make web pages.
Yeah, I mean they don't have to be perfect, and you don't have to be a wonderful designer, and you don't need to make Twitter, but if you at least try, you are going to realize that there is a lot of interesting stuff you can do with it, and then you just shoot for the stars.
Cool. Well, thank you very much, Emily, and to you, Lynette. Thanks to everybody who's taken part in the broadcast today. If you want to find out more about the Women Tech Makers series, you can find that on developers.google.com/women-techmakers, and this video also appears on youtube.com/edu@google. We'll be back next week with another couple of interviews to start to finish off the series. So thanks very much, and have a good afternoon. Bye.